Hello everyone. Today we're going to do problem 2095 from LeetCode. It's called delete the middle node of a linked list. Let's read the question. We are given the head of a linked list and we want to delete the middle node and return the head of the modified linked list. The middle of the linked list is defined as the floor of the length divided by 2. And we're going to see here in this example, we have an odd number of values. So the middle is pretty simple. It's just the 7 right here in the middle. We can see that. And if we have an even amount of values, then it's going to be this 3 right here. So our main issue is that we don't know the length of the linked list. And we could create kind of like a sub function that just calculates the length. We're going to run through with a pointer that goes through all the nodes and checks the length. Then we can calculate what the middle point is. And that's totally fine, and we could do that. There is actually a much more elegant solution using this idea called fast and slow pointers, which shows up quite a lot in linked list problems. So we're going to implement it that way, and you'll see when I start coding this up what the idea is. So let's start with creating our fast pointer. We're gonna set it to head, and we're gonna have a slow one, also gonna set it to head, and then we're gonna have another node that points to previous of slow. And this is because when we delete a node from a linked list, we don't want to just cut off the linked list. When we delete the node, we want to keep it going. We just want to kind of skip over that node that we're deleting. And now we're going to do some edge cases. If head equals null, or if head next equals null, we're going to return null. I hope this is pretty self-explanatory. That's just because we don't have a middle. And then otherwise, here's what we're going to do. And this is where the idea of fast pointers is going to come in. Well, fast and fast. Next, here's what we're going to do. We're going to call previous of slow to be equal to slow. We're going to increment slow to be slow next. And we're going to say fast is equal to fast. The next one, and then the next one again. And if you're going to have this aha moment, that's good. Essentially what we're doing is we're finding the middle of the linked list by having one pointer iterate twice as fast as another one. That way when fast reaches the end of the linked list, slow is actually going to be perfectly in the middle of the linked list, just as we want it. And this kind of saves us the whole hassle of finding the length first and then doing that calculation to find the middle point. This just kind of does it for us. And then the last thing we want to do is just get rid of that node in the middle. So we're going to say previous of slow at next is equal to slow at next. And then lastly, I already have it, but we're going to return the head. We're going to hit submit. And hopefully, as long as I didn't make any silly mistakes, there we go. We're going to see that this worked. And this also saved us some running time instead of going through the whole linked list first. I hope this made sense to you guys and maybe helped you guys out. If you have any questions, leave them down below. And yeah.